Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to look at how to solve exponential equations. We have been doing a lot in the last few weeks about exponential expressions. Today we're going to look at exponential equations and how to solve exponential equations. What is an exponential equation? Well, here is an exponential equation, and I'm going to start off with the very easy exponential equation. 4 is equal to 2 to the x. Well, in an exponential equation, the exponent is your variable, is your unknown. In an exponential equation, your unknown, the unknown, which is usually your x, the unknown, is the exponent. And that's why they call it an exponential equation. The unknown, your x, if you will, is in the exponent, is the exponent. And we all know what, if I had this equation, what x would be. If 4 is equal to 2x, it's clear that 2 is equal to x. Why? Since 2 squared is equal to 4. So this is going to be new and exciting ground, exponential equations. They're going to be very prevalent next year in pre-calculus. And what kind of equations have we solved thus far? Thus far in our math toolbox, we've learned how to solve linear equations. We've been working on linear equations for a long time. 4x plus 7 is equal to 3 times x plus 1. We're not going to solve that, but everybody could solve this equation if they had to. This is called a linear equation. They are easy to solve. The other type of equation we have solved thus far, we did a lot this year on quadratic equations. What's a quadratic equation? Well, 3x squared minus 2x plus 7 is equal to 5x minus 2. That's a quadratic equation. What makes it quadratic? Because it has that the variable isn't the exponent. It's because the variable is to the second power. That's what makes something quadratic. When you have the variable to the second power, it's quadratic. When you have the variable to the first power, as these are to the first power, it's linear. But when you have the variable as the exponent, that's called an exponential equation. So let's do some more examples of this right here, exponential equations. Okay, I just wanted to review what type of equations we have solved thus far. We've solved linears, we've solved quadratics. Now we're going to solve exponentials. And we have been using laws of exponents. We have been using our laws of exponents, and I'm not going to repeat these laws because you should have them in your notes. We're going to use the laws of exponents to, what are we going to do? Solve exponential equations. So you're going to need to pull out your notes because we're going to use the laws of exponents today. All right? So here's a little bit, here's it, and I'm just going to start going through some examples of exponential equations. This is going to be example 2. We already did example 1 back there. If I have 1/2 is equal to 2x, well, what's x? Well, I know, do I not, that 1/2 is the same as 2 to the negative 1. If 2 to the negative 1 is 2 to the x, that says that negative 1 is equal to x. So the method of solving exponential equations in this video is to get like bases. You want to get like bases, and then once you have like bases, then all you're going to do is set the exponents equal. So you're going to get like bases, and then you're going to use this property. If a to the b is equal to a to the k, if this is true, what do you know? Well, automatically then you know that b is equal to k. So this is all we're really using, is this method right in here. We're going to get like bases, and then we're going to set the exponents equal, because this has to be true. If a to the b is equal to a to the k, b is equal to k. And we will examine in pre-calculus why this is true. Today we're just going to assume that this is true, and it is. You can trust me. Okay, and that's what we did on this right here. We saw that, well, they don't have like bases now, but I took this guy and I made it with a base of 2. 2 to the negative 1 is 1/2. This, now I have like bases, and I set the exponents equal. Okay, let's do another example here. Let's do a little bit trickier one. This is example 3. All I'm going to do on this video is to go over several examples. This is going to help you with one of the IXLs that will be assigned. So again, it looks like, oh, what will be my like base? It's going to be 2, because I know 8 is 2 cubed, so I have 2 to the 4x is equal to 2 cubed. Since 8 is 2 cubed, now I have like bases. All I do now is set the exponents equal. So what do I do? Well, now I know, if this is true, that 4x is equal to 3, and now I have a linear equation, and x is equal to 3/4. Okay? And you could try that. You could check your answer. How would you check your answer? You can always check your answer. You're going to put 3/4 into this x, so what has to happen? 2 to the 4 times 3/4 better equal 8, and it does. 4 times 3/4 is 2 cubed, and that does equal 8, and we can say check OK. All right, so let's do another example here. Let's do one here. Here's example 4. I have 1/9 is equal to 3 to the 4x. Now I'm not using the base of 2. There's only so many bases that I'm going to use. 2, 3, 4, 5. So, this time I'm going to use base of 3, it looks like. And what is 1/9? 1/9 is the same as 3 to the negative 2. It's getting like bases. Like bases. That's the trick. That's the trick, getting like bases. Okay, so now I have 1/9 is 3 to the negative 2, which is equal to 3 to the 4x. Now it's easy. Now I can take and say, hey, negative 2 is equal to 4x. Solve for x. Negative 1/2 is equal to x. We can check our answer, but we will forego checking the answer. If you want to check your answer, you can. Okay, let's do example 5. Example 5. You can see the examples are going to get progressively a bit harder, but not that harder. So I have 8 to the 4x minus 5 is equal to 2 to the 4th power. Guess what we're not going to do? We're not going to simplify this guy right here. Do not simplify that. You would be a silly head if you did. What you're going to do is to get like bases. And what are the like bases? 2. 8 is 2 cubed, so 8 is 2 cubed, so I have 2 cubed to the 4x minus 5 is equal to 2 to the 4. And keep in mind, if I'm going too fast, you can always pause the video. Pause. And now we're back. And what am I going to use here? You got it. I'm going to use the power rule of exponents. And so this is going to be 2. When you have a power to a power, you multiply. So 3 times 4x minus 5 is going to be 12x. Minus 15 by the distributive property is equal to 2 to the fourth. Now I have my like bases. What I had to use this power to a power rule where you multiply the exponents. Okay, so what's this going to be then? Oh, well, now I know that I'm going to set the exponents equal. Sorry, I almost didn't set the exponents equal. And now I have a simple linear equation. I'm going to add 15. And I'm going to divide by 12. And that's the solution. So that's a little bit of a dandy problem right there. Okay, x is 19/12. All right, so let's do another example. Okie dokie. Let's go to another page. Let's go to example, I believe this is example 6. Example 6, let's go here. Here you go. I have 1/6 to the x minus 3 is equal to 36. All right. Well, clearly looks that I'm going to use 6 as a base, and I am. And I know from previous discussion that 1/6 is the same as 6 to the negative 1 to the x minus 3. 36 is 6 squared. Now I have like bases. I'm going to use the power to a power rule and multiply these exponents. Negative x plus 3, use the distributive property, negative 1 times x, negative 1 times negative 3. So that's going to equal 6 squared. Now I do indeed have my like bases. And what am I going to do? I'm going to set the exponents equal. Do the exponents in black this time. Subtract 3, and x is equal to 1. Okay, very good. Very good. And we're going to end this video with one more example here. And this is going to be example, I believe we're at example 7. If I have 2 to the x times 2 to the 3 is equal to 1/8, how am I going to do that? Well, I'm going to have to get one equation where I have one base on both sides. So if I'm multiplying like bases here, 2 base times 2 base, that says that this is going to be 2 to the x plus 3. That's the multiplication property of exponents. Like bases, you add the exponents. 8 we know is 2 to the negative 3. And now I have like bases. Good deal. And what do? I set the exponents equal. And x is equal to negative 6. So that's a short little 13-minute video on how to solve laws of exponents. This video is going to help you with IXL, I believe this is IXL Algebra 2 Standard S4. So, and then we will have a Google form and maybe a written example, and I will have 2 more videos this week. I thank you very much, and I will see you soon.